Hey, we've got here today another integral. This one's from the MIT Integration Bee 2025 regular season 11. We have the integral of square root x plus square root x squared minus 1 dx. Okay, I really like the problems where we have the nested square root situation like we have here. And what we want to think about is usually in an integration bee, when you have something like this, what's inside is most likely going to be a perfect square. We do have some formulas for this, but let's just look at something really quick. If we take square root of a plus square root of b and square it, we're going to get, first we'll have the sum of these two terms. When we square these, we're just going to have a plus b. And then the middle terms, we're going to have plus 2 square root of a times b. So if the stuff we have inside the radical is in this form, then we just put it back into this form where it's a perfect square, and then we can essentially cancel the square root with this, and then we probably have something easy to deal with. But we need to figure out if it's going to work and how's it going to work. And the first problem we have is we don't have this 2 here in our problem. Well, that's going to be easy to create. We can kind of just, we can multiply in. If I multiply in by square root of 2 over square root of 2, then we'll just leave this one out, but this one we can distribute inside the radical because this is also under a square root. So how it's going to look, we'll basically just distribute in a 2. We'll have square root of 2x now plus 2 square root x squared minus 1. This is all over square root of 2. And now that we've created this 2, we can kind of line it up with this and try to get everything to match. So we want a plus b to be this. So we're saying a plus b equal to 2x. And then we want what's inside the radical, a times b, to be x squared minus 1. So we want this right here. But now this is going to be pretty easy to solve. You could do it a bunch of different ways. You could factor this and do it that way or kind of eyeball it. But I think I will just kind of do it on the fly. So what we can do, x squared minus 1, x squared plus 1, x squared minus 1. I can factor that as x plus 1 times x minus 1. And you'll notice that basically works right away. If I call this thing a and this thing b, when we come back up here, when you add those together, the ones cancel and you get 2x. So we could set it up that way, where we'll just set a equal to x plus 1, b equal to x minus 1. And then we can just take these a and b values, plug it back into this thing. If you want to do it out just so you feel good about it, if you just square this thing out, right, do this, what you're going to get back is that. And so again, we're going to have this thing inside the square root, and we can essentially cancel this with this. Technically we want absolute value, but because square root's always positive, we don't need it here. So we can just take this thing here, square root of x plus 1 plus square root of x minus 1, throw it back into the numerator and continue from there. And now here we're in good shape. We have the same constant on each of these, so I can bring this out front as 1 over square root of 2. We could break it into 2 integrals, but I don't think we need to. And we can just put it like this, and it's going to be power rule. You could do a u substitution, but it's not necessary when the derivative of what you'd be substituting for is just going to be 1. So the u sub, if it helps you, you could do it out just to see how it works, but it doesn't really do anything because you're just going to get back dx equals du. So what we'll do is we'll just go ahead and we'll use power rule on these. So the first term is going to become x plus 1 to the 3 halves, put the reciprocal in front. And then here on the second one, x minus 1, 3 halves, reciprocal in front. And then let's just clean it up and bring the answer up here. So I can factor 2/3 out of each of these. Let me simplify this first. So we're going to have 2, 3 squared root of 2. I feel like with having 2's, a lot of times it's fine to leave that, and we could leave it, but I think in this case it might be polite to rationalize it, because then this is going to cancel with this, and you just have square root of 2 over 3. So we'll use that and put it together. And so for my final solution on this, we get just square root of 2 over 3 times x plus 1, 3 halves, plus x minus 1, 3 halves. Add a plus c on there, and that's it. Okay, there you go. Good problem from MIT 2025. Thanks everyone for watching. Have a good day.